Hey everybody, so this is just a quick tutorial on how to work the phases of the moon homework assignment. The very first thing that's important to know is that before you do this assignment, you need to make sure that you complete your coursework. In other words, make sure that you watch the lecture videos, make sure that you read the material in the textbook, and make sure that you at least have gone through it to the point where you think and you feel like you understand the concept of the phases of the moon. Otherwise, if you do this assignment without doing any of that, you're just guessing. And remember that this assignment is worth 20 points, just like any other of the homework assignments. And you really don't want to just throw away 20 points simply because it's the last second or you're confused and you're just going to take some shots at it. So the other thing I want to mention is that if something's confusing and you have questions about this assignment, make sure that you send me a message through Canvas and we'll try to coordinate a way to answer your questions. So again, feel free to contact me. But again, what's important is that you make sure that you try to understand it first. I've had students in the past who just dive right into the homework and then they're very, very confused. And the reason why they're confused is because they didn't do their part. They didn't try to understand it before they attempted the homework. So again, make sure that you do that. So the basis of the homework is pretty straightforward. What we have learned is that the phases of the moon that we see in the sky are the consequences of how we see the moon relative to where we are on Earth, as well relative to where the sun is and the moon is. So in other words, the sun, the moon, and the Earth, all three together, and how they're oriented towards each other is going to create the phases. The result of that is that there are going to always be three factors, or we're going to call them details, that are related to each other. The first one is the time of day, so what your watch would say. And for this assignment, we're going to make it even more simplistic. We're just going to simply say things like sunrise or noon or sunset or midnight. But to be technically correct, you could actually use the time on your watch or the time on a clock. So the time of day can be very specific. But for this assignment, we're going to keep it very generalized. The second one is the position of the moon, and what we mean by the position of the moon is where the moon is seen in the sky. So an example is the moon currently rising? Is the moon currently setting? Is the moon directly overhead? Is the moon, beneath your feet where you can't see it on the other side of the Earth, etc.? An example is this photograph that you see right here. This is a picture that I took, and strangely enough, this was actually Christmas Eve, and it was many, many years ago. This is 5 or 6 years ago. And this is, of course, a waxing crescent moon that was about to set. So this was the horizon, and you can see the moon is getting very close to it. So when we say where is the moon or the position of the moon in the sky, it's something like this. Sometimes you watch the moon set, sometimes you watch it rise, sometimes it's directly overhead, sometimes it's halfway in between, etc. The third factor is the phase of the moon. And what we mean by the phase of the moon is pretty straightforward. Is it new? Is it full? Is it a waxing crescent? Is it a waning gibbous, etc., etc.? So literally, what is the phase of the moon? Now, the way that this works is all three of these rely on each other. So this one and this one and this one, they're all intertwined. So if you were to know two of them and the third piece of information was missing, what you know of the first two will tell you the third. So in other words, the time of day and the position of the moon is determined by its phase. So in other words, what the phase of the moon is going to determine these two things here. Or if you know what time of day it is and you know the phase of the moon, well, those two things determine how you're going to see it in the sky. And then another third example would be if you were to, let's say you went outside and you looked at the moon and you noticed the moon was in a certain spot in the sky, and you notice the moon has a certain phase, well, then you could predict what time of day it is. So all three of these rely on each other. So if any two of them are known, the third one can be figured out. So the homework assignment is related to that. What I'm going to do in the Canvas assignment is I'm going to give you 10 questions, and in each of the 10 questions, one of the three pieces of information is missing. And your job is to take the two pieces that are given and to figure out the third detail. So I'm going to give you 2 details. You figure out the third one based on the 2 that I give you. Now, there's a diagram that is quite useful, and we'll put it in Canvas as well for you to have or to use. And it's a diagram that's very similar to the one that was used in the lecture, if you are watching the lecture videos. This diagram here is looking down on the North Pole. So let's start off over here. See where it says looking down on the North Pole of the Earth. So the idea is that this yellow dot right here is the North Pole coming right out at you. So, think of like a stick in the ground that's pointed right at your face. So this is the North Pole. And of course, that means this would be the equator of the Earth. Think about that for a moment. Make sure you understand North Pole down to the equator. This is the moon in its orbit, and the sun is way off to the right. And of course, none of this is to scale. The sizing and the distances are not meant to be accurate. But the sun is way off here towards the right, and the sunlight is coming in from right to left. The top is showing you the phases that you would see, what the view of the moon in the sky would look like. And the moon is numbered in its position, and the numbers go together. So in other words, if you are at position 1 for the moon, let me be more correct, if the moon is at position 1, so if the moon is in its orbit at position 1, then it would look like this in the sky. And so the idea is, of course, the moon is being lit by the sun on the side opposite of us, and so therefore we wouldn't see the side lit at all, and for us it would be a new moon, would look like that. So again, in the lecture, we go over much more detail about how this works. So this diagram is meant to help you, and one of the things that the diagram will also include is it will include the time at the various positions on Earth relative to the sun. So what this means is if you're standing right here, then it is noon, because if you notice, the sun is directly over your head. If you're standing right here, then the time of day is sunset, because you would have to see the sun on your horizon. Midnight and sunrise are similar. So this information, of course, is going to help you in the assignment. And let me give you a little bit of advice. This diagram is very helpful when it comes to doing the assignment. Take your time. What's important is that you draw a picture. And what I'm going to do in a minute is I'm going to show you some examples and tell you more about that. But the other thing is to go slow, think about the questions, think about the positions, try to visualize. And it's important that you try to understand this diagram to the point where you don't need to have it. So an example is, in the next exam, there are going to be questions where this diagram isn't going to be readily available. And if you spend all your time trying to look at this diagram to answer the questions, you're going to run out of time on the exam. So the exams are actually timed very tightly so that you can't just simply hopefully look through your notes at everything. So what I'd recommend is that you try to understand this diagram. Now, if it means memorize it, that's one thing. But I would say just try to fully understand it. If you do your homework and you do the reading and you watch the lecture videos, the phases that you see and the positions of the moon relative to the sun, that should all make sense. So if this is clear and it makes sense and it's understandable, then this diagram is helpful, but it's not necessary. But we're going to make it available for you for this homework assignment. Now, what I'm going to do is I'm going to switch to a whiteboard, and I'm going to show you some examples of how to do this assignment. And we'll start off with a few easy ones, and we'll work to some harder ones. So let's go ahead and make that switch now. Okay, so here we are. We're going to do a couple of examples for you so that hopefully you can work through this homework assignment. The first one I'm going to do one that's kind of simple, and I'm just going to completely make this up as I go. I'm not going to try to work on any specific question from your assignment. So what I'd recommend is that you watch this, follow this carefully. But again, I'm just kind of going to make it up as I go here. Let's start off with something simple. The first thing is that it's important that you try to draw a picture. A picture is really, really important. If you try to do this in your head, you're going to get confused. Things get tangled up. Things get sort of backwards. So again, I'm going to use this whiteboard, but I would use a sheet of paper if I were you and draw a picture for each one of the questions. That way you get everything sort of straight and you keep things sorted out. So let's start off with something easy. Let's say the time of day, we're going to call it noon. and the position of the moon in the sky. Let's make it even easier, and let's just say, I'm going to abbreviate it here. Directly, DIR, directly overhead, OVH for overhead, and my left-handedness is going to slowly erase this as I go. And then, of course, the question is, what is the phase of the moon if these two things are true? So the way that it works is, let's switch to our picture here, and a couple things to remind you of. Remember that when we draw a picture like this, or if you use the diagram that I provided for you, both in this video and also on our website, or on the Canvas page, I should say, diagrams that are shown like this, in this case, this is looking down at the North Pole. So this is the North Pole of the Earth. In fact, what I would do is I'm going to erase the E, and what I'm going to do, just to make sure we're clear on that, I'm going to put a dot. And that dot is the North Pole. Imagine the North Pole sticking right up at you, okay? And so the other thing to remember is that when the Earth is going to naturally turn on its axis, if we're looking down on the North Pole of the Earth is going to rotate on its axis counterclockwise. Okay? And so you'll see in a minute why that's going to be kind of an important thing to know. Let me clean this up just a tad. Okay, so noon on a diagram that I provided for you, but if you can kind of use some logic, you can figure that out without the diagram. So the sun is over there, it's in that direction, and we're looking down at the North Pole. And so that means this is the equator. So think of it, if this is the North Pole, that makes the circle the actual equator going around the Earth here. And so let's just assume that for each question in your homework that you're at the equator. Just makes life easier, but let's just make that assumption. So if it is noon, that means you have to be standing on Earth. I'll make a little stick figure here, like that. So you would have the sun directly over your head, the sunlight coming down on you. Let's call it noon, with the sun directly overhead. Now this is saying the moon. Make sure you're clear. This is the moon's position. And if we say the moon's position is directly overhead, and here you are, then the moon directly overhead would be right here. Okay, and so if the time of day is noon, if the moon is directly overhead, the last step is to figure out what the phase is. And if you learn what the phases are, or if you use that diagram, preferably I'd rather you learn it and not need the diagram. But looking down on the North Pole of the Earth, this position is going to be a new moon. So the phase of the moon, for both of these two to be true, I'll put a little circle around it or a square around it, is new. So if it's noon and the moon is directly overhead, the phase of the moon has to be a new moon. Okay, let's do another one. Let me get my little cool eraser here. I'm going to clean this up by getting rid of that, and I'm going to get rid of the person here. Okay. Let's do another one that's sort of easy, maybe a little bit harder. Let's do the time of day is sunset. Let's do one of those. And, excuse me, the moon's position, let's do this. Let's call it rising. And then, of course, the question is, what is the phase if these two things are true? It's the same deal. Draw a picture, North Pole, Earth rotates counterclockwise, orbit of the moon, sunlight coming in from over there. Time of day is sunset. Now I'm going to get rid of these arrows to free up some space. But if you use your diagram, you'll see that sunset's position is up here. So that's where you would be if the time of day is sunset. Now that's great if you use your diagram, but what I'd prefer is that you understand why that's sunset without using your diagram. Let me close this gap right there. The reason why this is sunset is that if you understand the concept of why the sun rises and why the sun sets, remember that when you watch the sun set, it's not really setting. What's happening is the Earth is turning and you're turning away from the sun. So the sun would be over here And if the Earth is turning this way, then you right here are turning away from the sun. So remember, the sun's over here, and if you're turning this way, you're turning away from the sun. So from this person's perspective, the sun is going to look like it's getting lower in the sky because they're turning away from the sun. Now, why does it make it sunset if it's right here? Well, that's because, and I'm going to switch to a different color, that's because this blue line would be your horizon line. In other words, you're right here and you see everything over your head. You can't see anything below your feet or below the Earth because obviously the Earth is in the way. So this is your horizon. So what you'll notice is that you're right here. See if I can do this without blocking the view too badly. And you're looking this way and you see the sun. But notice from this person's perspective, the sun is going to look like it's on the horizon. So the sun is somewhere over here. Got to do this sideways, forgive me. And so from your perspective, the sun looks like it's on the horizon. Now, simultaneously, let me switch my colors. The Earth is turning counterclockwise. And so if you're right here turning like this, and the sun is on the horizon, at that moment, you're watching the sun on the horizon at the same time you're turning away from it. So this person watches the sun look like it's getting lower and lower and lower in the sky. And at this point, the sun is crossing the horizon, getting lower. So this person watches the sun set from this position based on where the sun is, from their position where the Earth is. So sunset. Now, if that didn't make sense, back up the video, watch it one more time, because it's kind of important to make sure you understand. Now, the moon is going to be seen rising from this position. Now, it's the exact same logic. So the moon, if it's rising rather than setting, therefore the moon is on the horizon. Remember, the moon doesn't really rise, it's just that we turn towards it. So you have to see it on the horizon while simultaneously turning towards the moon. And for those two things to be true, the moon has to be right here. This person would see the moon on the horizon while they're turning towards it. This would be the moon rising. So the time of day is sunset, the moon is rising. The final step is, what is the phase of the moon when those two things are true? And you can see that if you have your diagram and you understand the concept of where the moon is at each phase, you'll notice that this is the position of a full moon. So a full moon is the phase when it's sunset and you're watching it rise. Okay, we're going to do one more example, and to be perfectly honest with you, I'm going to kind of redo this just because it's kind of a mess. I don't know if you can hear on my microphone, but the trash guy's out there. It's trash day. Trash truck picking up the garbage. Let's see, I'm going to put the Earth back. Okay. Now, what we're going to do is we're going to do one that's a little bit different, because you'll notice when you do the homework assignment, some of them are going to say some odd things. So we'll do one that's a little bit different. Let's see. The time of day, let's say, is midnight. And the position of the moon is, and I'm going to abbreviate this, but some of your questions are going to say halfway between, I'm going to abbreviate it, directly overhead. Sorry about the abbreviations. It just speeds things up. Halfway between directly overhead and, let's say, setting. So halfway between directly overhead and setting is the moon's position. So the question, of course, is what is its phase? So let's do that one. Time of day is midnight. And again, midnight, if you understand how all this works, midnight's going to be right here. Why is this midnight? Because you're here, and you'll notice from this person's position, the sun is below them. It's beneath their feet. And if you're here and the sun is on the opposite side, then it has to be midnight. halfway between directly overhead and setting. So let's kind of map that out. So this would be directly overhead, and this is going to be setting. Now the question is, why is this setting when this is not? So let's go through that. Remember, this person, their horizon would be something like that. Okay, horizon line, you know, think about how the dome of the sky and their position, and this is their horizon. So this would be the horizon, this would be the horizon, this is either rising or setting, this is either rising or setting. How do we figure it out? Remember, the Earth turns counterclockwise. So if the Earth turns counterclockwise, you are here turning towards this direction. You're turning this way. So anything right here, you're turning towards, anything right here would look like it's going up. It would seem like it's rising because you're turning towards it. And anything right here from your perspective would look like it's setting because you're turning away from it. So you're turning this way, so anything's going to look like it gets lower. So this is the position of setting for this person. This is the position of rising for this person. This is directly overhead for this person. We want setting. So we're going to get rid of this one. Setting position, directly overhead, halfway in between. Halfway in between puts the moon here. Now the next step is, what is the phase? And if you understand how this concept works, this would be the phase of waxing, and it's going to be a gibbous. So this is waxing, gibbous, abbreviate it, waxing, gibbous, moon. Okay, waxing gibbous moon for this particular phase. Okay, we're going to do one more example just because I want to mix it up a little bit, because some of the questions that you're going to have, get rid of this, get rid of that, and let's just get rid of all that. Some of the questions that you're going to have are going to ask you for not the time, not the phase, but it's going to ask you for the moon's position. So there's going to be a variety of things. So let's do the one where you're solving for time. So I'm going to make this up as we go. Let's say the phase is third quarter. Bring that to the party here. I'm going to abbreviate it. Third quarter. And let's say the moon is setting. And then, of course, that leaves the question of what is the time. So let me draw the circle for the Earth again. So the moon's position is setting, the phase is third quarter, and we need to know the time. So this is a little bit tougher. For these questions, start with the phase. Third quarter moon is going to be right here. So this is just because this is where the third quarter moon always is. If this is the phase cycle, looking down at the North Pole, moon goes in its orbit like this. So this is a third quarter moon. No choice. That's where the third quarter has to be. Now, the tricky part is, where are you to watch this set? Where are you to watch the moon set? So I'm going to show you two possibilities. One possibility is you're either here. The other possibilities are either here. Now, why is it that you're not here? Because if you're here, you can't see the moon at all. So somebody standing right here can't see it. Why is it you're not right here? Because if you're right here, the moon is directly overhead. So it can't be this position. It can't be this position. It's got to be one of these two. Now, the moon is setting. So that means for something to set, you have to turn away from it. So which two of these two is going to be the person turning away from this moon? Well, remember, the Earth turns counterclockwise. So this person down here is going to have the moon, let's draw it in, on the horizon, but they're turning towards it. This person right here is going to have the moon, and let's make the moon bigger to make this realistic. This person is going to have the moon on the horizon, but they're turning away from it. So this person is turning towards the moon. This person is turning away from the moon. This person sees the moon rise. This person watches the moon set because they're turning away. So we want setting, which means it can't be this person. This person sees this moon setting. It's a third quarter moon. The time of day is the sun is directly overhead. The time of day, think about what it is. is noon. So if it's noon, directly overhead, the moon from this person is going to be setting while it's a third quarter. So notice how these three things come together.